Hey guys, IE.RVT here, and we are looking at Module 5, Homework B, Tab 1, Part 6, Series Capacitors-Energies. Capacitors-Energies, yeah. I believe this is the last part to this question series. So we know that the energy stored in a capacitor is given by U is equal to 1/2 times C times V squared. However, since we have the same charge Q of T on each capacitor in a series configuration, we can also express the energy in terms of charge. So you have U is equal to 1/2 times Q squared, all divided by C, where Q is the charge on the capacitor and C is its capacitance. So in a series circuit, the charge Q sub T on each capacitor is the same and is related to the total voltage V and the equivalence capacitance C of T. So we have Q sub T is equal to C sub T multiplied by V. And we already know that the total capacitance for the three capacitors C1, C2, and C3 in series is going to be C sub T is equal to 1 divided by 1 over C1 plus 1 over C2 plus 1 over C3. And we found this in a different part. So now we can calculate the energy stored in the capacitor using the formula. So for capacitor 1, we have U1 is equal to 1/2 times Q sub T squared, all divided by C1. And then for capacitor 2, we have U2 is equal to 1/2 times Q sub T squared, all divided by C2. And then for number 3, we have 1/2 times by Q sub T squared, all divided by C sub 3. And those are our answers right there. And I believe those should work if you put them into Snape physics, and don't forget to put your multiplication signs. So each capacitor stores energy in the electric field created by the separation of charges. In a series configuration, the same charge flows through each capacitor, but the voltage across each one differs depending on its capacitance. The energy stored in each capacitor reflects its ability to store energy for a given charge. The factors of 1/2 in the energy equations arise from the integration work done in charging the capacitors from zero charge to their final charge. Since U depends inversely on capacitance, capacitors with smaller capacitance values will store more energy for the same charge Q sub T compared to those with larger capacitance values. This shows that the distribution of energy across capacitors in a series circuit based on their individual capacitances. And I hope this helped.